What happens to things left in the vast expanse of space? Imagine a satellite, its mission complete, drifting silently through the cosmos, or a tool dropped by an astronaut tumbling away from view. Do these objects simply exist, unchanging in a cosmic museum? The reality is far more dynamic. Space is not an empty, inert stage. It's a harsh and unforgiving environment that relentlessly works upon anything it encounters. Instead of pristine preservation, objects in space face a different fate, a slow and steady transformation under the unrelenting forces of the cosmos. One of the most fundamental characteristics of space is the vacuum, a vast emptiness that stretches beyond our imagination. Unlike on Earth, where we're constantly surrounded by a sea of air, providing us with the oxygen we need to survive, space is almost entirely empty, devoid of air and other gases. This lack of atmosphere has profound effects on anything venturing beyond our planet, from satellites to astronauts. For one, there's no air resistance in space, allowing objects to move freely. This means objects, once set in motion, will continue to travel in a straight line indefinitely unless acted upon by another force, like gravity or collision with another object. More importantly, the vacuum means there's no protection from the sun's intense radiation, which can be extremely harmful. This constant bombardment can drastically alter the makeup of materials over time, causing them to deteriorate and weaken, posing significant challenges for space exploration and technology. Space is a place of extreme temperatures. Without the moderating influence of an atmosphere, objects in direct sunlight are subjected to intense heat, while those in shadow experience frigid cold. This constant cycling between extreme temperatures takes a toll on materials. Imagine a piece of metal left in space. As it bakes in the sun, it expands. When it rotates into shadow and the temperature plummets, it contracts. This constant expansion and contraction weaken the material, leading to cracks and fractures. Over time, even the most robust materials can crumble under these relentless temperature swings.
Section 4. Matter. The vacuum space and the radiation don't just affect objects on a large scale, they also impact at the molecular level, altering the very building blocks of materials.
Radiation, in the form of high-energy particles, can penetrate materials, breaking down chemical bonds and weakening their structure over time. This process, known as damage, can embrittle materials, making them more susceptible to cracking, and even change their color, leading to significant degradation. Think of how plastic left out in the sun too long becomes brittle and faded. Applies, but the effects are magnified in space. Processes are more intense. Harsh environment of space, where materials are constantly exposed to extreme conditions. Understanding these changes at the molecular level is crucial for developing material that can withstand the rigors of space travel and exploration.
Section 5. No life, no decay. Unlike on Earth, where organic matter decomposes due to the action of microorganisms, in the vacuum of space, there's no such decay. Instead, a different process occurs: sublimation. Sublimation is the transition of a substance directly from a solid to a gas, bypassing the liquid phase. In the vacuum of space, any water or other volatile substances within organic matter will sublimate, leaving behind a dry, desiccated husk. So, while things don't rot in space in the traditional sense, they are fundamentally altered by the extreme conditions. Section 6. A different kind of transformation. When we think of objects left in space, we might imagine them floating eternally in a state of suspended animation, untouched and unchanged by the passage of time. But the reality is far more dynamic and complex than we might initially believe. Space is an active participant, a cosmic sculptor that reshapes and transforms anything it encounters, constantly at work. Objects left in space don't simply remain static, they are in a continuous state of change. They undergo a slow and inevitable metamorphosis, shaped by the relentless forces of vacuum, radiation, and extreme temperatures, which act like invisible hands molding them over time. It's a reminder that even in the seeming emptiness of space, the universe is always at work, constantly reshaping and remolding itself, a testament to the ever-changing nature of the cosmos.